that we understand what useEffect is and how it fits into component lifecycle, let's see it in action. One of the most common use cases for useEffect is fetching data. Let's dive into the code example. So I'm going to create a new component called data fetcher. Let me type the code first and then we'll talk about it. All right, we are done. So let me explain the code that I just typed. So we start by importing useState to store our fetch data right here and useEffect to manage side effects, which is used here. The data state variable holds our list of posts. We are using fetch with JSON placeholder, which is a website that provides dummy data like user posts on a blog, which we can experiment with. The data state variable holds our list of posts and set data updates it once the data is fetched. Inside useEffect, the fetch call happens after the component has rendered. This ensures that the DOM is ready before any data is fetched, preventing errors or timing issues. The empty dependency array over here, which is the second parameter of useEffect after the callback function, means the effect runs only once when the component first mounts. This is ideal for actions that don't need repeating, like initial data loading. And remember, if you don't provide this, and if I totally skip this variable, this useEffect will run every time this component mounts or re-renders. We handle errors to prevent app from crashing and log them to console for debugging. And finally, in the return statement, we are displaying the post that we have received through the fetch API. So initially, data would be an empty array because we initialized it so, but after the fetch has completed, the component would re-render and display the fetched posts. I think we are ready to try this data fetcher component out. So I'm going to copy this, save this, go to app.jsx and replace the previous ones with this one. And let's go to a browser. And here it is. Notice how the fetch happened just once. At the moment the component mounted, the empty dependency array in useEffect ensures the useEffect doesn't run again. All right, we are back in the code, and this time we are going to try an example where useEffect runs multiple times, but only when a specific value changes. So as before, we are going to write the code first, and then we'll explain. For that, I'm going to reuse this counter example. So I'm going to copy this and create a new file count tracker.jsx, and I'm going to make it a bit less convoluted than the previous one because that was meant to show some other problems. So let me make the code changes. Okay, we are done with code changes and we are going to see how dependency array truly shines in this example. So we are using a state variable called count, which is incremented every time we do a button click. So each time we click the button and count changes, useEffect needs to run again, logging the current value to the console. So it would only execute if the count value changes. So let's see that for ourselves. All right, the count is now 0, which is the initial state. So now if I click the button, 1, 2, 3, and notice that the initial state also changes the value of count when the state is initialized and this value is applied. That is also considered a change to the variable's values. So the first run of this use effect would be when this line executes. And afterwards, anytime an external event like a user click is happening, count state variable is being updated and we are seeing the result being tracked by useEffect. But here's the interesting detail. By including count in the dependency array, we prevent the effect from running on every render. Instead, it only activates when it's needed, making the component more efficient. This is crucial for optimizing performance and avoiding unnecessary side effects. Okay, our last and final example of use effect would be a cleanup function example. So for that, let me create a timer.jsx file. Let me write the code and then I'll explain how it works. Right, so side effects sometimes need cleanup. If you're setting up a subscription or a timer in useEffect, you should return a cleanup function inside useEffect to avoid memory leaks. In this example, we create a timer that logs timer is running every second, but we'll also see a log message when the cleanup function is triggered. And this is the syntax for cleanup function. In a useEffect, you just return with a function taking no arguments, and that acts as a cleanup function. So when this component unmounts, we should see that console log cleanup function called. But to trigger the unmount, we need to do something extra this time. So I've got this export default line again. Right, so we need to make some changes to the parent component to make this component unmount. So I'm going back to f.jsx, doing these changes, and I also need to do some extra changes. So let me make those and then I'll explain. All right, now in the app component, we added a toggle button with state to mount and unmount the timer component. Here we are only showing the timer if show timer state variable is true. Otherwise, it would not be shown, and this would essentially means unmounting the component. So if we run this example, we should see the cleanup function logs if we unmount the component. So let's go there and oh, it has been running for a while now. So let me refresh. All right, the timer is started. So if I click toggle timer, you see the cleanup function is called and no more timer is running logs coming up, which is great. So every time you create side effects that persist over time, like timers or event listeners, always include a cleanup function to prevent memory leaks. In this example, we cleared the interval when the component unmounts, ensuring no unnecessary processes continue running in the background after you have moved away. So that brings us to the end of the use effect section. By mastering use effect, you can create responsive, efficient components that handle real world behaviors. Whether you are fetching data, setting timers, or subscribing to events, this hook gives you full control over side effects in your application. Now let's explore more advanced scenarios and best practices.